Here what we've got is a power supply, a switch, and this power supply and switch are connected to this solenoid. So I don't know if you can tell, but inside of here there's a bunch of copper wire round and round, over and over and over again. And so when I close this switch, hopefully you see some current flow, right? Okay, and so now what I have is a piece of iron, all right? I'm going to put this piece of iron right here. Now it's not actually touching any of the copper or anything, and I want you to think about what should happen when I close the switch. In particular, I close the switch, the solenoid is energized, okay? There will be a B field created here. What should that do to this piece of iron? Okay? You could also think, what type of magnetism does that piece of iron? So can you see the current at the same time?
Yep.
All right, let me move this just so it's a little clear. Is that okay, that position?
Yep.
Here we go. Ready? 1, 2, 3. So hopefully you saw that get attracted and it goes inside. All right. Does that make sense? Yes, there's a magnetic field here that's going to align the domains in this and it brings it inside. Now the brain teaser is, what if I switch the polarity? So if I switch the polarity, which way will the rod move this time? Again, I haven't closed the switch. Pause the video and take your guess. Okay, here we go. 1, 2, 3. It still goes inside. So the idea is, remember, this piece of iron does not exhibit a ton of magnetism. When you first put it inside there, it gets magnetized slightly, but only a small amount remains. When you polarize this the opposite way, rather than being ejected outwards, it's easier to realign the domains and bring it inside. So a practical application of this device is literally a doorbell. The idea is you could actually use some current to cause a piece of metal to strike another one like this, whoops, and ring the bell. All right? Interestingly enough, if I close the switch for a short enough time period, right, watch what happens when I close it for a long period. Can you get an overhead view of that, Angus? Okay, so watch what happens from the overhead view. Here we go. We see it oscillate, right? The idea is it has enough momentum to overshoot, and then the magnetism brings it back, and eventually friction slows it down. If I could switch it for a short enough time frame, it should fly all the way through. Oops! Oh! That was slightly too long, right? It made it all the way through and started coming back before I... Let's see if I can do that again. There we go. And so you can imagine this basically being like a coil gun. Anyways, all right, that's it.